Good morning, good afternoon again, Matrix. So we're in our third segment of analytical geometry. We're still talking about the circle. We've looked at the equation of the circle. We've looked at how do we work with these equations that are not in standard form and change them so that they look in standard form so that we can extract the center from that and the radius from that, right? Now let's look at this phenomenal, this wonderful phenomenon, that the fact that we know that a line is a buildup of a lot of points, right? It's just a lot of points that are very close to each other that we join and we make a line, right? A circle is similarly the same. It's just a buildup of a lot of points. And we plot those points, we join them and we make a circle, right? Now think about this whole phenomenon, that a buildup of another points that go straight like that, and a buildup of a lot of points that are going in a circular direction, the fact that they meet at that one singular point that is the same for the circle and for the line. We call this whole phenomenon a tangent. And the tangent, we call it, it's a tangent to the circle. And we know one thing about this tangent, mathematicians have studied this, is that whenever there's a tangent, this tangent makes a 90-degree angle with the radius. That our tangent always makes a 90-degree angle with the radius. That's the whole phenomenon of a tangent. It's a line that touches the circle only at one point, right? And so what do we know about our knowledge of gradients, and gradients particularly that are perpendicular to each other? So we know from our grade 11 analytical geometry that the gradient of the radius multiplied by the gradient of the tangent is equal to -1. And you guys are saying, but sir, how do we know that? Well, you know for a fact that if I have perpendicular lines, remember in normal analytical geometry, and I'd find the gradient of AB, and I didn't need to find the gradient of CD. I'll just take the gradient of AD and I'd multiply it with the gradient of CD, and that will be equal to -1, and I could calculate what the gradient of the CD was. Do you remember that? So that follows from what we know from our grade 11 analytical geometry. How are we going to use this? How is this very important right now? Well, it's important because in this segment of the video, we're trying to find the equation of the tangent. So we're trying to find the equation of this dotted line down here. Well, it's going to be a solid line, obviously, but we're trying to find the equation of that line. And how does this help us? It helps us because we don't actually need 2 points on this line. If we have 1 point and we know we have the gradient of the radius, then we can always find the gradient of the tangent. And if we can find the gradient of the tangent, we can find the equation of the tangent. So that's what we're doing today. Let me just erase this. This was just an intro, but we're going to need that formula there at the end. But the objectives of today is we're trying to find equation of tangents. That's what we're doing today. And I needed to use this formula because that's what we're going to be practically looking at today, right? So let's take an example. I'll give you this one where we're given the coordinates of the center B given the coordinates of A there, which is 5 and negative 6, and then you're told that there's actually a tangent that goes past A. Try and draw this as accurately as possible. Right? You're told there's a tangent that goes past A. And the question asks you, find equation of tangent. Right? And so what are we going to do? First of all, you need to construct this dotted line right here. Sometimes it's going to be given, sometimes you're going to have to construct it yourself. And why am I constructing it? Because I know that that dotted line will be my radius. Any point from the center to the circumference is a radius, right? The line of a point from the center to the circumference is a radius. And so if I know that's a radius, then I could just calculate the gradient of A and B. So I'm going to calculate gradient of A and B, and that's going to be y of A minus y of B over x of A minus x of B, right? Y of the A is the negative 6, y of the B is a negative 5, so it becomes a positive 5 when it goes into my equation. The x of the A is a 5, and the x of the B is a minus 2. So if you add those, you get a minus 1 at the top, you get a positive 3 at the bottom. So my gradient of A and B is negative 1 over 3. You agree? So that's how I find the gradient of A and B. And now I need to find the gradient of the tangent, because what are we finding in this whole question? We're trying to find the equation of the tangent. So I need the gradient of the tangent, and I'm going to use this formula up here. So m of A and B, or rather let me just say radius, times m of tangent is equal to negative 1. M of the radius is the negative 3 over 1, negative 1 over 3. M of the tangent, so m of the tangent is just going to be a positive 3. You can calculate that yourself. You just divide by negative 1 over 3 on both sides, you get a positive 3 on the right hand side. So now I got the gradient of the tangent. What do I do with the gradient? I use this formula right here. Y is equal to mx plus c. The great formula of a straight line. I had my gradient, which is a 3. Substituted my gradient. What point do I substitute to find the coordinates of C? Think through that yourself. What points do I substitute to find the coordinates of C? Remember what we're trying to do here. We're trying to find the equation of that blue line. Well, it looks blue to me. Hope it looks blue to you as well. Of this blue line that goes across there, the tangent line. So the only coordinate that we have that is on that line is the coordinate of A. So we cannot, by any case, substitute the coordinates of B there. It wouldn't make sense because we wouldn't be understanding what we're actually doing, right? So think through what you're doing. Always think through what you're doing. So I substitute the coordinates of A there, negative 6 for the y, positive 5 for the x. These multiply, they give me 15. They go to the other side. It says negative 6 minus a 15. And so the C value is negative 21. Remember what they're looking for? They're looking for the equation, so let me just put the equation here. Y is equal to 3x minus 21. Do you understand what happened here? So let me just run you through the steps again. First step is that we needed to calculate the gradient of the radius. Right? After calculating the gradient of the radius, we use this formula, the one that says perpendicular gradients are always equal to -1. And we use that to calculate the gradient of the tangent, which we got as +3, right? We use that +3 as the gradient of this equation here, and we calculated the y-intercept. Obviously, there's no Cartesian plane here, but if you were to draw your Cartesian plane, that means this line would cut at -21. Now we got that. We need to give them the final equation, which is y is equal to +3x minus 21. So let's look at another type of question. All right, matrix, getting back to this. We're given this type of question. I hope you can see it. We have a circle there. That's the point A there. And from there, there's this tangent that is formed, the tangent AB. And we're given the equation of that tangent, which is this guy right here. We're given that the P is the center of the circle, and that on the other end there's a C that forms. So A and C makes a diameter, and on the other end the C makes a tangent of CD. Hope you can see that. And on the other side as well, we have E down there, and then makes a tangent of EF. And we asked all these questions here, so it's going to be quite a long example to go through. But I hope you guys stay with me and you actually get all the juices out of this question. So the first question we asked is equation of AC. So there's an A and there's a C there, and we asked for the equation of that line. So one thing we know is that we know this equation, which y is equal to 2x plus 30. So if we know that equation and we know that this is a diameter, it's a radius, then we know for sure that we can use that gradient up there, right guys? And so I'm going to say gradient of AB multiplied by gradient of AC is going to give me -1. So what I'm basically saying is that that gradient times this gradient will give me -1. And then what do I do with that information? I use the gradient of AB there that's given to calculate the gradient of AC. And so I know that the gradient of AC is going to be equal to -1/2. Right? If I divide by 2 on both sides. Then I got the gradient of AC. What point can I use to find my intercept, my y-intercept? I have to use that P value because we don't have the coordinates of A there. So the only other point I'm given is that P value, the center. So I'm going to have to use that equation, that point. So y is equal to mx plus c. I substitute my gradient first, right? Substitute the coordinates of P, which is 2 for the y, and then -3 for the x. So we have a -2 there. We end up with a 2 plus a 3/2. And so my C is a 5/2. Right? 2.5 plus that's 1.5. Yeah, 1.5. Yeah, gives us 2.5. So we get this, And what is the equation of this? Y is equal to negative 1 over 2x plus 5 over 2. That is number 1 done. So we can tick that guy. Probably going to need space, so if you need to copy this down, you're going to have to pause the video. But I'm going to need that equation probably. So let me just try remembering it. I'll put it up here. Y was equal to negative 1 over 2x plus 5 over 2. I think so. Wait, is that what you get? I remember having a y was equal to 2. I'm sorry, I'm checking something. I think I might have done a mistake here. X plus c, and so I substituted these coordinates to that side. A 3, negative 3 there. Also, this gives me a positive. And so when it goes to the other side, it gives me a negative. Sorry. So C is actually a half. I'm sorry. So this guy here is a half like that. Oh, it's a good thing I noticed that. So we got a half. There's our equation of AC. We're done with question 1. Question 2 says calculate the coordinates of A. And A is right there. So you guys think through it. How do I find a coordinate of a point right there? First of all, what I want you to think through is that there's a line that goes like that, which we given the equation, and there's a line that goes like that, of which we just found the equation. So what do we do to actually find the coordinates of A? Hope you guys are alluding now that you need to equate the equations, so make them equal to each other, because at that point they will be equal to each other. So that's what I'm going to do. I'm going to say y of the 1, or y of the AB rather, is equal to y of the AC, right? So what am I going to substitute? The left hand side, that's the one I'm interested in. I'm going to solve for x first. Right? If I take this to the other side, I get 2x plus a half x. Take this to the other side, I get a half minus 13. I add these, I get a 5 over 2. If I subtract those, I get a minus 12 and a half. Right? Divide by 5 over 2, divide by 5 over 2. X is actually equal to, just check there, 5. Is it a positive 5? No, it's a negative 5. It's a negative because of that negative. So X is actually equal to negative 5. Then how do I find the Y? I could use either one of those equations, either this or that one there. So I'll choose that one there. So Y is equal to 2 of the negative 5 plus the 13, negative 10 plus 13, you get a positive 3. And so the coordinates of A are negative 5 and a positive 3. And what you do in analytical is that you always need to use you need to be thinking through these questions. So does it make sense that I got a negative x value? Yes, it does make sense, because I'm on the negative side. Does it make sense that I got a positive y value? Yes, it does make sense. So I'm going to put these coordinates right there, just so I don't get them and I can erase all of this. Right, and with that, we're done with question 2. And question 3 says it wants the equation of CD. Ooh, now they want the equation of that guy. Right, how are we gonna go about doing this? So one thing we know for sure is that we have the gradient of that guy. We can use that guy, but we're gonna at some point have to find the coordinates of C, because there's no other point that we have there on the line to actually find the y-intercept. Do you get what I mean? So yes, we're gonna have to find the coordinates of that C value. How do we find the coordinates of that C value? We're given the P, we're given the A, and so we use midpoint formula. So midpoint formula says if I have the x of the A plus the x of the P divided by 2, then what I'm gonna get, if I have the x of the A plus the x of the C, then if I add them and I divide by 2, then I'm gonna get the x of the P. I'm gonna get the midpoint, this point right there, right? And it says similarly that if I have the y of the A plus the y of the C divided by 2, I'm gonna get the y of the P, of the midpoint there. You understand? So that's what I'm gonna use to actually solve for the coordinates of C. I have this guy, I have the coordinates of A, the only thing I'm trying to find is that guy. I have that guy, I have that guy, the only thing I'm trying to find is that guy. So I'm going to use the fraction, I'm going to quickly calculate it down here. So coordinates of A for x is -5 plus the coordinates of C, that's what I'm looking for, and all of this is equal to -3. If I multiply by 2 there, and if I multiply by 2 there, I end up with a -5 plus cx is equal to -6. So x of c is equal to -1. So my 5 goes to the other side and adds, and already I can put my -1 in there. Got it? How do I find my y value? I use that fraction there. I'm going to write it down here. Remember, I'm working with the y's now, so it's a 3 plus the y of the c, all equal to 2. How do I get rid of that? Times with the 2, times with the 2. That cancels. 3 plus y of the c is equal to 4. Take the 3 to the other side. Y of the c is also equal to 1. Well, it's +1, so I can already write this coordinate, -1 and a +1. So that's the coordinates of C. Remember why we were calculating these guys? Because we couldn't actually find the equation without those coordinates. And that's what this question wanted us, the coordinates, the equation, sorry. So now we have the coordinates. We can use the gradient of this guy to find the gradient of the tangent. And we know that gradient of AC times the gradient of CD is going to give me -1 because it's a radius and a tangent. I have this one here. I'm looking for that one there. So m of CD is actually equal to +2. So guys, if you're actually thinking through these, you were going to see that that's actually a +2. The fact that it's a tangent that side and there's a tangent this side means those guys have to be by virtue parallel to each other. Got it? But I needed to prove it. But I hope you guys were thinking through that the gradients of those guys are going to be the same. So now I have the gradient. Y is equal to mx plus c. The gradient I'm going to use is 2. The coordinates that I'm going to use to solve for the C is the C coordinate, which is a positive 1 for the Y, negative 1 for the X. So you multiply, you subtract, you add on the other side, so you get a 3 is equal to C. Right? And so the equation of this guy is Y is equal to, where's my gradient? So 2x plus 3. Right? Got it? So we nearly there, guys. We passed our halfway point. Right? So now they want the equation of the circle. Ooh. Remember for a circle what we needed to get the equation? We needed the center and we needed one of the points at the circumference. Or we needed the radius. So you could do one or two things. You could calculate the distance of AP and you know that's your radius. You just square that value and your radius squared, you already have it. Or you could go the long way and you could just substitute these coordinates. Actually, I don't know which one is quicker, so I'm just going to try substituting the coordinates. So this is the equation we're using, remember? That's the equation we're using, equation of a circle. Coordinates of the C there, well, C I mean center, not the C coordinate. By C I mean the center, so it's the P coordinate plus 3. It's a Y there, sorry. Minus 2 all equal to R squared, right? Now what else do? We substitute one of the coordinates, so you could use C there, or you could use A, whichever one you prefer. I'm going to use A, seems closer to me and more accessible. Squared 3 minus 2 squared. You're solving for R, you add these, you get a minus 2, you squared, you get a positive 4. You minus these, you get a positive 1, you squared, you get a positive 1 still. So my R squared value is actually equal to 5. Right? Beautiful. And so therefore, the equation of this guy, let me put him in green because he's very important, is x minus, well, x plus the 3 squared y minus the 2 squared all equal to 5. So that's the equation of the circle. Hope you guys are noticing the pattern. It's gonna look the same, guys. As long as you practice a lot of these, you're gonna start seeing the pattern. It looks the same. There's nothing new in math, guys. There's nothing new in math. All right. So now the last thing, the equation of E and F. There's E and there's F, and that's, we asked to find the equation of that line. So let me draw a dotted line going there. I'm going to put my 90 degrees there to remind myself. So I know I'm going to have to find the coordinates of E, right? Because that's, let me think through this. Ooh, sorry Matrix, my diagram looks a little bit weird. I hope you noticed it because the coordinates of C don't actually make sense for it being like that and it's underneath. So it's just the way I drew that diagram that makes it very confusing. But actually the coordinates of E was supposed to be on the axis. So it was supposed to be up there, and that's how we're going to be able to find the coordinates of E, because we're going to be saying that the y coordinate is 0. So we're going to put 0 there, and we're going to use the equation of the circle to solve for the coordinates of the x of the E there, right? So that's how we are going to do it, but I won't do it now because seeing that my diagram is a little bit messed up. The coordinates of C here are correct. The calculation is just that the place that they look in the diagram looks weird. So forgive me, I'm going to end the video here, and the last video will be quick, it will be short, because yeah. Thank you so much, Miss Trix. Sure.